Hello everyone. Today in lesson 6 we are going to look into data classes for structural data. We have looked into various methods, how do we call the methods in Python. But Python is basically a object-oriented programming language. So today we'll look into a bit more detail how does the Python class looks like and more specifically into data classes. In subsequent videos we'll go through the Python classes in detail. Right. So as we know, right, in C Sharp 9 the new data type came, which is record, right, which are immutable value based data that carries that generate the equals or hash code and toString automatically. It's something like class, but we don't have to define them. It's something we just define only the properties we needed. So Python also has something similar starting with Python 3.7, that's called the data classes. It also does something similar. It define all the let's say the basic boilerplate methods like init or representation or equals automatically, which are we have to define in a specific class. Okay, so before we go into data classes, let's spend some time looking into how does the class looks like in case of a Python and in case of a C Sharp as a comparison, and then from there we'll move to the data classes. Okay, so let's say I have two side-by-side comparison, right? So we have the C Sharp classes, which are let's say we define a class person, define certain attributes or properties like name and age. Then we define some methods like toString, equals, get hash code, which are required whenever we want to compare two different person object, right? And this is how we define the constructor, even with a parameter or without a parameter. Now coming back to Python, it's something very similar. We define class and class name. Then like C Sharp we have a constructor. In Python we have underscore init, and there we need to pass whatever properties variable we need to pass as a constructor parameter and assign the value something like self dot name. Like in C Sharp we have this dot name, but this is not always we have to mention, but in Python we have to indicate self dot name, self dot s, which will refer to the current object, right? So like we have the toString method in C Sharp, in Python we have underscore representation, right? So they will say how does this class will represent itself when we want to print this specific class. Similarly we have equals method and hash code method, which works in the similar way how C Sharp to equals and hash code method work. These are typically useful when you do the person or the object comparison of two different object of the same class type. Okay, so now let's say look into various methods that are there in specifically in a class and compare them, right? Again, with something we've already looked into, like we constructor we define with a class name in the C Sharp. In Python we define with underscore init. So when we create a new object of the class, we use new and the class name, but in Python there is no such keyword new. We just define the class name and pass the constructor parameter. Similarly, to convert to string we use toString. In Python we use underscore representation, or Python also have underscore str, but usually repr method is more generally used. Similarly all other properties, right? So now having understand how does a class look like, now let's go to the next session regarding the data classes, right? So with the data classes we don't have to define the method like init, representation, equal, hash code, all those method we don't have to define. So system will automatically generate them for us, so that our data class will look very clean. Okay, so now moving to a data classes, right? So now data classes is quite similar to the record as I mentioned before, right? So record, how do we define a record? We just define type as record, then the record name, and we define the parameter that would be part of the record. Something similar in Python, when you define a data class, we use the attribute data class, okay, or we call in Python it's called decorator. So we use the decorator data class, which apply to a class, then define the class and just define the properties or the attribute that we need in the class. So we don't have to define any let's say boilerplate methods like init, string, representation, hash code, all those things. Okay, so that's how C in Python we define a data class, and in C# we define a structure record, right? So now Python, there is also we need to can define this data classes as a by default these are mutable, but we can define them as immutable by marking them frozen. So we'll go through all those details when you go through various examples of what are the use cases of data class. So we'll not go through class in general in detail. So this lesson is more about the data classes. In the subsequent lessons we'll look more into the class. Okay, so now what we see for a data classes, so all those methods that by default define, we don't have to define. So what does it literally mean? We can just compare two objects of a data class type, and if the values for the remaining all the attributes are same, or all the properties are same, then the object would be equal. Okay, now Python also have something called post init, which actually runs after init. This method also has been defined automatically for a record. Now on the right hand side there are two different use cases in a record. We'll go through them in detail when we go through the Visual Studio exercises. But how do you define a default value for a record, or how do you mark a data classes as a frozen, right? So that we cannot change the value once it is defined, only once it's instantiated as part of the object creation, but after that there are no changes can be made. Okay, so now the final comparison, various types are there, right? Whenever we pass some set of values, sometime we use dictionary object where the local grouping of the data. But let's say we want to define an object or a class which has lot of methods, or there are behaviors are assigned, then we go for a regular classes. If there are only data is there, only properties are there, then we go for a data class. Something similar, how can you define a person, right? Similarly, if you define a configuration, configurations are once initialized, we don't change. For example, our AI configuration, which will make a call to the AI OpenLLM, right? So all those things, once you define a data class, we don't want to change across. So those things are defined with a data class frozen equal to true. So this makes the data class as a immutable. Similarly, if we want to enforce schema validation or serialization of data automatically to JSON object, whenever we make an API call, we make use of Pydantic model. We'll talk about Pydantic package in detail in the subsequent lesson. But today's lesson, let's zoom into the data classes into more detail. So now we'll go to Visual Studio and get started with the data class. Okay. So before we start today's Visual Studio examples, so I wanted to introduce a package called Jupyter. You can add it as a Visual Studio extension. What does it provide? It provides a capability as a line by line comparison or a block by block code execution. So we don't have to actually execute the complete Python class file or a Python file altogether. We can write a code snippet, execute it, and see the output right there. So it is very much useful when you go for any AI development programming. You want to try out some part of the code to verify it's working, then go for the next block of the code. Jupyter Notebook comes very handy. Okay, so once you install Jupyter Notebook, we have to go to Visual Studio file and let's create a new Jupyter Notebook. Okay, so Jupyter Notebook extension would be .ipynb. So I'll just say test.ipynb. Okay, so once you create a Jupyter Notebook file, this is how the interface will look like. Okay, so let me increase the font. Okay, so this is a Jupyter Notebook interface will look like. So there are three different sections are there. First thing is to AI generate some piece of code. We will not use that one. Second part is a code block. If you just click on plus, you can write any code here. For example, I can write import data classes from data classes. Okay, so anything we can write it here. Similarly, on the right hand side, if I want to write some comment, we can just plus mark down. So this is just an example. Okay, so when you execute this particular code block, it will only execute the code. This markdown syntaxes, it will not execute. So if I go from let's say, okay, let's write one small example, then we go for the detailed one. For example, I can just follow it, I can execute it here like this, it can get the result out. Okay, so before we proceed, right, so in the Python notebook or Jupyter notebook, we have to select which virtual environment it will use. Either you can click on select kernel here, or you can try to run, it will ask to select kernel. So here I'm selecting my local kernel, which is defined within this particular folder. So it executed, there is no output. So let's say I want to type something and get a output. I can type something and then run the program to get a output. So that's the reason the Jupyter notebook comes very handy. So today I have already prepared a lot of data classes example in Jupyter notebook file, and again this notebook file or the Python classes file I will add and upload to the TechWebFit blog website. You can find or download it from there. Okay, so let's look into Jupyter notebook file. Okay, so let's start. So first thing first is to use the data classes, like we have to import the data classes from the data classes module. And then let's say how to define a simple class. Let's start with defining one simple classes. I define one simple class called AI chart message, where it defines some properties like self.sender, message, type stuff. Then I define one method called isSystem. Okay, now you see here the underscore init method is there, which act like a constructor for this specific class. So now to create an object of the class, you can just call it like AI chart message and pass the value as per the parameter what we need, and I run this one. So there are two different things I want to highlight to you. One is printing the class itself directly, and then printing the dictionary representation of the particular class. So if I run the class now, so here we see the whenever we print a class, default it print as an object, right? But when you go for the underscore dictionary, it actually convert the properties inside the class into a dictionary of key value pair and prints it. So now we have not overwritten the representation method or the string method here within the class. So this is how the default class will get printed whenever you want to print it. Okay, so now let's go to the next example, which will talk about how to define a data classes. So we'll define now similarly class, data class, and here there is no init method. We just define the properties directly, but it will have one decorator called data class. So once this decorator is applied, this class will behave like a data class, and data class decorator will automatically create all the boilerplate let's say methods like your init method or your string method or representation method, or it will create that automatically. So here also we can define any method we want, which is similar to how to define in a class. So now to create a object of type a data class, exactly same way how do we create the object of type class. Okay, so you can define the data class name, then you can define whatever the properties or attribute you want to pass. So now let's say I want to create two different data class object. One is user message and one is system message. I pass the variable, I just print it. So if we print it now, so here we see, so there is some error. Okay, so what the error? It's saying the name error for the data classes. Okay, so the reason we have not executed the first line. So without, it's always go from the top to bottom. So once we run the first line, so now the data class object or data class keyword, data class method decorator is available. Now if I go ahead and run it, okay, so it printed two things. One is chart message user and second one is chart message system. Now here we see whenever we print the data class object directly, it just printed a good representation of this particular data class. So we don't have to define underscore underscore str or underscore underscore representation, or also it did not print something like a class default print, right? So that's how the behavior is already overwritten. It makes it easy to use the data classes. Okay, now let's move on. Okay, so how do you define a data class as a immutable? So what do you mean by immutable? So here I can already change the value. For example, after I define a user message, print a user message, I can always go, I can define user message and assign any value. Okay, user message, let's say I want to change the sender, I want to change the system to system. Okay, so if I define something like that and I, let's say I print it again, print user message, okay, so there is no error. Okay, so initially it is user, but once I change to system, it changed to system. That means we can change the value of a data class. But let's say I want to define a data class as a immutable. So once defined, I don't want to change, right? Usually we use this for the configurations, right? So that's where the data class decorator has additional parameter called frozen. So if define frozen equal to true, then the data class would be immutable, right? So now I'll go through the same method, but I'll try to change the value. I try to assign the value after object has been created. So if I run it now, we see it will give us the error. The error saying frozen instance error. That means the instance is a frozen instance, so we cannot change the value. So we use this frozen decorator whenever we want to define any configuration that's not supposed to change during the execution of your application. Okay, so now let's go to the next example to define a specific class called enum. Like C# we have enumerations, right? Or enums we have something similar in the Python. We can define a class as a enum by inheriting from a enum class. Okay, it's like a C# we are inheriting from a base class, right? So it's something similar. Whenever we want to inherit one class from another class, we just want to pass that particular base class as a parameter of the parent class. So base class is a parameter of a child class. Then we say sender type is inheriting from enum, and now it itself is a enum. And how to define the different enum values? We can define various properties and what is the value equivalent. Okay, so now let's try to use this enum. So now I change the sender type in my class or data class to a sender type enum, so that we can pass the value like sender type dot user. Okay, and also when I want to compare, I can just compare sender type dot sender equal to sender type dot the value like a system to define if it's a system or not. Okay, so let's run it. So here we see how is the value has been defined and the dictionary whether it's a system or not. So that's how we use this enum type to define various let's say enumeration values, so we don't have to hard code the string type often. Okay, so next example we will go through. Let's say we want to define certain properties, right? We know these are the fields and values are there, like C# where you have the getter, setter and the properties. In Python also, if you want to define a property, then we can define with a decorator property. That means any method within a class with a decorator property will act like a property. That means if I want to print access the total token, I can just use object dot total tokens. Okay. So let's say we'll go to the let's try to print this value and then we define. So I want to create, let's say this is chart response. We'll create response 1, which is the response from a chart response object, and then I'll print the response. Then let's print the total token, and let's print the is confidence. Again, is confidence is a method, but total token is a property. So now if you see the total token, there is no bracket, but in case of is confident there is a bracket. So now let's run it. Okay, so total token is actually executed the input and output token, but it actually used as a property instead of a method. Okay, so now let's go to for last section for the data classes, how to define in a real world a data class object for a configuration, right? So that means I define a model config class, and again I mark it as a data class and frozen equal to true. Then I define various attributes within or fields within this particular class. Then all these fields I define some default value. Okay, that means if the value is not passed, it will take this value as a default value. Okay, so now whenever you want to create an instance of a data class model config, if I don't pass anything, it will take the default of values. But if I want to override certain value, for example model name I want to change from GPT-4 to GPT-3.5, or max token or temperature I want to change, then we can only pass those values. Then whenever it will actually all other values will be taken as a default. So if I now run it, we see there are two different model config, and only the values that we pass in the second parameter, let's say second in object creation, which overrides the default value, while all other values remain same. So that's pretty much all about the data classes. The key things to understand is when to use data class and when to use a normal class. So in case we want to use a standard as our focus is more on the fields or the members of a particular class and define as an object, not so much into let's say we want to run something during the initialization, or we want to customize the initialize or toString, and then we tend to go with normal classes where we can define a lot of method, complex logic. So normal classes is a right choice. But when you want to just define a placeholder for our data objects, so then we go with the data classes. Again, whenever you want to define a data class as a configuration object, for example we have a JSON options, or we want to create a model config, in such cases it's always ideal to define as a data class frozen and then pass the value with the default value defined. Okay, so that's pretty much all about today's lesson. So I'll again upload the Python file and the Jupyter notebook file in my blog. So stay tuned and download the files. Thank you everyone. Everything we covered today, including the scripts, the configuration, the extended documentation, is available right now on techwayfit.com. While you are there, check out our deep dives into various technical blogs like on enterprise security, design principle, or put your skills to the test with our develop focus quizzes. And if you're ready to master the intersection of the .NET and AI, subscribe to the channel and I'll see you in the next video. Thank you.